Welcome everyone to the second episode of the Clean Water series with Proline Fittings. Now, pardon the informality, but I am super stoked about today's guest. But before I get into that, let me quickly recap the first episode in case you missed it. The Clean Water series is a program that Proline developed to provide information, positive light to the waterworks universe, to take a deep dive into the technical aspects of the latest and greatest products on the market today, to share stories and best practices with the hearts and minds of waterworks professionals. In tangent with the Clean Water series, we're also establishing a fund to support and promote and encourage education in the waterworks industry. Now, during the first episode, I said the word about 14 times in the first 3 minutes, and to watch that now is a little bit frustrating, to say the least. So what I'm doing is, on this episode, anytime I say the word about, I'm personally donating $20 towards the fund, and hopefully I don't say about too many times. But enough about that. Let's get to our guest today. I'm very excited. Our guest today has over 30 years experience in waterworks. She has a master's in engineering from the University of Toronto. She has experience in the private side as a consultant, as well as in the public sector as the director of engineering with the City of Kitchener. She has dedicated the last 15 plus years of her life to the intimate understanding of inflow and infiltration. She's now the director of Norton Engineering, and to top it all off, she's not afraid to dive into a sewer and get her hands dirty. Welcome, Barbara Robinson, to the show.
Thanks so much, Justin. It's great to be here.
I'm so glad that you decided to join us here. So, Barbara, first, very simple question for folks out there is, what is inflow and infiltration?
Yep, that's a very easy question to answer. Inflow and infiltration are both clean water that get into sewers that should not be there. So when we design new sewer systems, we design them for a certain amount of flow, a certain design flow, which has to do with domestic flow. And then we add on a little extra kind of a safety measure for inflow infiltration that might be generated in the longer term. But the inflow and infiltration we're talking about a lot these days in Canada, across North America, is excessive or unacceptable inflow and infiltration. So inflow is typically a direct connection to the sanitary sewer. So that would probably be something like a catch basin lead from the storm system that was accidentally connected to the sewer. So inflow is anything kind of direct like that. And then infiltration is more groundwater seeping into sewer, so that more has to do with cracks and things in the sewer. They're both clean water. Both of those sources of water should not be in our sewers because we need to save that space in our sewers for sewage.
Okay. So now, is this something that's limited to aging infrastructure?
Absolutely not. So that's kind of the core of my work. My Norton's research has primarily been on the phenomena of inflow and infiltration getting into brand new sanitary sewers. So these are sewers, most of my research has revolved around subdivision construction. And these are sewers that are brand new subdivision sewers that absolutely should have zero, they shouldn't have zero leakage. There's a small amount permitted, but they should have very little leakage. And what my findings and data have shown is that these sewers are leaking badly, and sometimes they're leaking 10, 20 times more than is acceptable per our own standards and guidelines. Wow. And the reason this has come to light, we didn't actually know about this until, I stumbled over it about 15 years ago, I suppose, is that we've always assumed that brand new sewers would be leak free. It never occurred to engineers working in the inflow and infiltration field that these brand new sewers would actually be contributing I&I. So we used to just ignore them. And, studies and research and background has shown that there is a lot of leakage going on in brand new sewers, and it is unacceptable. It has to stop.
Wow. So in a brand new subdivision, we're putting in homes, we're putting in sewer systems. There's infiltration happening in a brand new subdivision.
Absolutely. Absolutely.
Wow.
Yes.
Wow. And so are there some tips and tricks or best practices to kind of prevent that from happening in a new subdivision?
Well, sure. There are lots of reasons why the flow is getting in. In a new subdivision, typically, well, first of all, there's only one person in the whole chain of the city, and the city project manager, and the contractor, and the developer, and all that. It's only one person who can actually build that sewer to be leak tight, and that is the contractor. Everybody else is gravy. You know, on the public side, we have public side inspections. On the private side, we have building code inspections. There are imperfections about all these different inspections. It's actually fairly complex to inspect a brand new sewer. So we don't necessarily send out 10 or 15 or 20-year engineers to do these inspections. We often send out students, and you know, which is fine. And we've all been students, and I didn't know anything about pipe when I was a student, but there are a lot of things to look for that perhaps we have been missing. So it's regulatory, it's not doing the inspections we're supposed to, it's not doing the testing that we're supposed to, and also just not flow monitoring, not actually collecting actual data which would tell us how much unacceptable clean water is getting into those sewers. So we have the tools.
Right. So it's an inspection thing that maybe isn't happening to the fullest degree that it could be happening.
Correct. Yeah.
Okay. I'm wondering about at a manhole connection. Is there anything around a manhole that also can cause infiltration?
Oh, absolutely. So the primary reasons that water gets into sewer pipes, it's not magic. The water gets in underground either at joints, at the connection of the mainline sewer to the manhole riser ring joints, the connection of the sewer laterals to the mainline sewer. These are all standard places where we always find I&I in older sewers. So what I want to see is that I&I not finding it in brand new sewers, because it should not be there. Yeah, so.
Okay. Yeah, it's interesting. Do you mind if I talk about a product really quick, Barbara?
No.
Okay, so yeah, we sell a product that's called Interlinks. It's designed to prevent permeation through a wall, usually when a pipe is entering into a building, but it also can work when pipes are entering into an existing manhole, say in a repair and replacement type of situation. And so what it is, it's a mechanical seal that forms a seal between the annulus, between the pipe penetrating the manhole and the core hole into the manhole. It's actually designed to withstand up to 40 psi of pressure. A common complaint is that they leak, and specifically it tends to be on the larger diameters and heavier pipes, which is true. And the reason for that is the heavier pipes, 14-inch ductile iron type of thing and greater, will actually, for lack of a better term, squish or compress the bottom 6 o'clock of the links. And so what Interlinks has done here is they've developed what's called the centering post. And so what it is, the polyethylene post that actually supports the weight of a heavier pipe. And then you still get the compression and the seal around the pipe, and now your top 12 o'clock of that pipe is not leaking. And so it's a newer product. Not a lot of folks are familiar with it. Maybe not. It's not something that would be used in new construction, but certainly in an old sewer system, it seems to be a handy product that solves the problem.
Okay.
Now, aside from well, let's just talk about cost. There must be a cost associated with I&I to municipality. Like, do you have any idea of what that cost might be?
Oh, I sure do. So that's one of the main drivers here. So if we think of, well, let's talk about the cost of flooding. And flooding is very hard to predict through I&I. I&I does increase the risk of flooding, but I can't assign a value to it because it depends very much on the sewer system itself and the circumstances around that sewer shed. However, and you say the cost of the municipality, but it's not actually the municipality who's paying the cost of this I&I. So you and I pay a sewer rates bill every month, and that charges you a certain amount of sewage use for the month or whatever the timeline is. And that number is basically your sewage use plus your fraction of the I&I that shows up at the wastewater treatment plant, and you just pay for it as a resident. And it doesn't say on your bill, your sewage use, 50% I&I factor total, it just says sewage use. So most residents and most councillors would not be aware that residents are actually paying for this I&I in their sewer bill. So that's one thing. So when I talk to councillors and all that, because that's where this has to go, we need politicians to understand what's going on with I&I and put the appropriate pressure on the developers and the contractors and staff and all these other people that are involved. They need to understand the cost. So the first study I ever did on this was I found leaking pipes in St. Jacobs, Ontario in 2005, I think. And we found 2 liters per second of unacceptable, like over and above allowable leakage in that sewer. And 1 liter per second, which is about a garden hose, that's what 1 liter per second looks like, an enthusiastic garden hose. 1 liter per second costs about $90,000 a year to treat at the wastewater treatment plant. So one little garden hose, in the context of sewer systems, that doesn't sound like much. That's a lot of money. So in this particular village, St. Jacobs, it's a very small municipality. They don't have a lot of dollars. They don't have the kind of money to start paying. So if we hadn't discovered that problem and fixed it, the residents of that township were going to be paying for that 2 liters per second. So let's call that $180,000 per year for the next 75 years. This is the problem. In brand new subdivisions, these sewers are designed to last 75 years. So it's not just a one-time leak. This is a permanent issue. So I've taken that data, and that was nowhere near the worst leakage situation that I've seen. I've seen places, I said before, 20 times higher than allowable in 5 or 6 new subdivisions in a municipality. So when I take those kinds of numbers, like what I saw in St. Jacobs, which was by no means the worst, and I start multiplying that by all the development we're expecting in the GTA over the next, till planning horizon 2041, we're into trillions of dollars of I&I getting discharged into our sanitary sewers that should not be there. And it's there because we're being careless with how we construct things. We're doing inspections, but we don't always understand what we're meant to be inspecting for. There's a lot of pressure on inspectors to move projects along. So there's a lot of pressure on an inspector to go ahead and approve things that might not be quite right. And inspectors have told me, I've heard from people across Canada, that if they're too rigid in their assessment or interpretation of how well something is done in the field and call the contractor on it, they get political pressure when they get back to the office, because councils and municipalities love development, and it's tax dollars and it's development revenue. So it's very, it's needed and it's wanted. So the appetite to actually make sure we're putting these sewers in correctly can be quite low. So trillions of dollars potentially going into sewers, and all the sewers that were built in new subdivisions up until I got onto this, whenever, let's call it 10 years ago, those are all just leaking away, whatever they were doing. Nobody ever checked them. They're all just leaking into our sewer systems now. So I certainly look at I&I in existing systems as well as I&I in new subdivisions. So yeah, there's a lot of different things going on here. There's something else I was going to mention that's very important. So and I don't deal with, here's a piece of pipe for you. I don't deal with large diameter pipes too much in my work. I tend to be using more local pipe. This is sewer lateral pipe. It's 4-inch, typically DR35, and it's PVC. Okay. And that's why we use PVC on the main line as well. What happens when we construct the lateral? So that's the pipe from your house to the street. Okay. When the mainline sewer contractor builds the mainline system, so the sanitary system and the manholes, and he builds the laterals for property line. He gets all that in place, leak tests it, gets it approved by the city, and then building activity starts. So, and what I'm trying to convince regulators and all that is to say we should be leak testing these sewers before we accept them. So that is a primary recommendation of my work. But these PVC pipes, the same pipe is being installed on the private side from the house to the property line. It's typically white on the private side. Same pipe, it's just white. The private side folks are not actually installing this pipe according to the PVC manufacturer specifications. So you used the word squish before, and I use that I use that non-technical word sometimes. So PVC pipe squishes with the weight of the soil on top of it. The only way to prevent that squish is when you're putting the pipe in, it needs to be carefully bedded. It needs to be embedded. So you need to haunch the pipe and support the kind of corners, shoulders of the pipe, and lots of compaction. So on the public side, we do all this, and we compact to 95% Proctor density, whatever. On the private side, they're not doing that at all. They are laying this pipe on the ground, grabbing an excavator and just dumping soil on top. And that is called an installation on the private side. This is not in accordance with the manufacturer's requirements for PVC pipe. It's in all their literature. I've been talking to building departments across Canada, you know, presented building, discussing the building code. The code does specify the same specifications as we have on the public side, but we're not following on them on the private side. So I suspect, it would be my professional opinion, that half of the I&I we're seeing on the private side, at least half. Oh, sorry, one other thing related to this. So also, pipe on the private side is glued. You can see this is a glued pipe. The public side one is gasketed.
Yes.
So with a gasketed pipe, you've got a little bit of play actually over a length of pipe. If it needs to move, it can move. Now, when we glue pipe, which actually was never improved, hasn't been approved for underground installation, but we're using it on the private side. When we glue a pipe, we create a rigid length of pipe, sometimes with about 3 joints in it for the length of the average lateral, a long, rigid piece of pipe. Any differential settlement, any rock under there, any, you know, lack of bedding, any squishing will cause the joints to snap.
Yeah.
So when I look at, of course, I CCTV, we video inspect old sewers or old laterals, and the joints are always leaking. And so I suspect it has to do with not installing PVC pipe properly, but also using these glue joints, which were never intended for underground installation. So that's regulatory. That's actually a standards issue that I'm working on right now as well.
That's very interesting. I'm glad you bring that up. Of course, we manufacture gasketed sewer fittings, and we're actually pretty proud about the way that we manufacture our fittings. So really, it starts with the gasket. And what we do is we take, it's actually, our gasket is a steel ring that's fully encapsulated in EPDM rubber. Then we take a superheated piece of PVC pipe and vacuum form it over top of that gasket. You know, sometimes you hear about gaskets in a sewer fitting rolling out or coming dislodged. In our fitting, that will never happen. In fact, before the gasket is ever dislodged from the fitting, it's going to get destroyed by misuse. So the other thing about our process is that it's automated. So we're able to get consistency and repeatability in all of the fittings that we fabricate and produce, all with that gasket system.
Awesome. So those mainline sewer gaskets are a huge problem in existing systems. So when we look at old CCTV tapes or recent CCTV tapes of older sewers, it's totally common to see a gasket hanging on the CCTV. And as soon as you have a gasket that rolls, this is quite common because in a larger diameter sewer, we have guys standing in the trench, and the excavator goes over to where the pipes are stored. The guys put chain around it, and he brings it back over and lowers it into the manhole. And there's a couple of guys standing there that try to, you know, shoehorn it into place or whatever. And I'm talking 300, 400 size pipes, not large diameter. So as they're trying to do that, the gasket, it's not unheard of for that gasket to roll. And actually, we're supposed to, one of the inspection requirements for pipe is that the gasket should be checked with a proving ring. Each and every gasket should be checked with a proving ring to make sure it hasn't rolled.
And that happens every time, right?
No one's doing that. But what that is, and I'm all about efficiency. I really am, because I spent my entire life in the private sector. I understand construction, and I get we're trying to get pipe in the ground quickly. I understand all that. Yeah. The guys that are standing in that trench, they're going to stand there while the excavator drives over to go get another piece of pipe and drive in the chain and drives back. They stand there for at least 5 minutes. They're standing there for 5 minutes. Why can't they check the gasket? I mean, this is so simple. But the other thing, and I should mention, because it sounds like a whole bunch of people aren't doing what they need to do, and that's not quite true. Right. People actually understand what's going on. I've been in inflow and infiltration my entire career. And I only stumbled across this 15 years ago and was just fooling around until I opened Norton when I kind of picked up this in earnest.
Right.
He didn't actually know. And we got to remember who's actually the contractor in the field. So this isn't the developer with trillions of dollars or those rich guys. It's a guy making 18 bucks an hour standing in the field. He doesn't know what I&I is. He doesn't care. He's, it's just not on their radar screen. So education is a huge part of what I do. So I do an awful lot of presentations and workshops simply to share information, give people resources to places they can go and check, and reasons why this inflow and infiltration is so problematic. And that's, let me go back to something I started to say before and I forgot. I'm so sorry. When I talk about having extra water in the sewers, imagine, again, I'll just visualize a new sewer because it's easier. So that sewer is empty, and some flow comes down the pipe, whatever, you've got 200 houses connected. So typically in a new sewer, because the minimum size is 200, that's actually very little flow in the bottom of a sewer. That's not very much in a small subdivision. Right. Now, if that sewer actually ends up with, another slice or two, an inch more of clean water, that means that the sewer that we've designed, we've sized it for engineering conditions. We've sized it for what it should be large enough for. When there's clean water in that sewer, we now have an undersized sewer for the application we put it in. And this is even more important in storm sewers. All of my research has been in sanitary sewers, but all of the comments, whatever, about construction are equally true of storm sewers. So in a storm sewer, we design a storm sewer for a certain return period, like say a 5-year storm. If you design a storm sewer for a 5-year storm and it's leaking and there's a whole bunch of either inflow or infiltration getting into the sewer, when a rainstorm happens, you don't have a 5-year storm protection anymore. You're down with 3-year storm protection. And with the advent of climate change,
you're starting with a partially full pipe now. With
the advent of climate change, we cannot afford for our sewers not to be large enough to convey these flows. I mean, having a safety factor of 20% would be our climate change safety factor right there. I mean, those are the kind of numbers we're throwing around about how to oversize sewers. So, and I'm not even going to get into the costs of flooding, but the emotional costs as well, the mental health costs associated with flooding are incredible. Quite aside from the $60,000 bill you might get if you have to redo your basement. A lot of complications going on here, actually. But
well, and all that water ends up, certainly on the sanitary side, ends up at the wastewater treatment plant, right? And so now we're treating all of this water that isn't supposed to be there.
Right.
And we haven't even begun to talk about combined systems.
Right. Oh, and capacity in the pipes is a huge thing as well. Certainly around the Greater Toronto area, many municipalities have capacity constraints. So some of our older trunks are at or near capacity. If we could build our new sewers without adding extra clean water, developers would actually get back capacity that they're always looking for by building their new sewers more tightly. And that's some of the messaging we do with developers now in specific municipalities where there are development constraints. We're saying, look, you build this subdivision, we'll put a flow monitor downstream. When we're satisfied that it's acceptable amounts of sewage coming out of there, great. We can release additional capacity because we're confident that those sewers have been built the way they need to be built. And I will say one other thing, something I have observed in my work, which is kind of interesting. When the developer and the owner and the engineer, the consulting engineer that's working for the developer, when they know that I have a flow monitor at the downstream end of a subdivision, we get much better results in terms of leakage.
Right.
And
somebody's watching.
And so we're capable of doing this. Like, we know what we need to do. We just need to be more careful. Ultimately, I don't think it would even cost any more time in the field. I think just public education, inspectors knowing a little more, the engineering inspectors knowing a little bit, everybody just understanding a little better what's going on, and councils understanding the impact of not doing this, the impact on their residents, basically.
But going back to what you said earlier, it makes sense to me if the citizens of Canada are essentially paying out of pocket for inflow and infiltration. It's like you say, it's nowhere on your water bill. That's incredible. But there's no impetus there to improve the situation if we're just blindly paying for it. So it's very interesting.
And let's remember, a developer designs a subdivision, builds it, and he takes risks. Obviously, they 10 or 12 years to get a development built, I think, depending where you are. He takes risks, but he does walk away with his profit. and he goes and spends, that's the world we live in. That's fine. But he's walking away with his profit, and then the municipality and ultimately the residents are left holding the bag to pay for this I&I, and that is fundamentally not fair, and it needs to change. And it is changing. It is changing.
So you mentioned flow monitoring. Can you explain that a little bit more in greater detail?
Yeah, sure. So a flow monitor is simply a monitor to measure flows. It goes into a manhole. They're pretty simple. We've been using them for years for various things. So it's typically they're area velocity meters, and we use Manning's equation to use the area and the velocity, depth and velocity to calculate the flow. So at the downstream end of a subdivision, we'll put a flow monitor in. I recommend they get put in as soon as we establish the trunk system. As soon as we start putting the mainline sewers in, we want that flow monitor in the ground, because that allows me to see what kind of I&I is happening initially, and then the system gets accepted and gets tested and accepted. And then when the private side starts getting built, when the homes start getting built, then I can have another look and see what's happening to the I&I then. So I can actually tell whether the I&I problem that I see is on public side or private side. So basically in engineering, we can calculate allowable I&I in a brand new sewer and a brand new, there is allowable I&I in a brand new sewer and allowable I&I in brand new manholes. It's very low, but we can calculate what that is. So I'll look at flow from a new subdivision. I subtract the allowable leakage per all of our specifications. Of note, of interest, is on the private side, the allowable leakage is 0. So even though it is construction, and typically in construction we do allow a little bit of leakage, building code says 0 leakage. So when it comes to that, we can pretty much say, well, we're not accepting because we're seeing leakage. But listen, I understand we're building things. It's not a perfect system. So I'm not trying to be a jerk about this. I look at flows. If they're close to where they should be, that's fine. I'm concerned about flows that are 2, 3, 4, 10 times as high. That's not
way beyond acceptable. Yeah.
Maybe aren't acceptable. Not to put too fine a point on it.
So that's interesting. And do you mind if I talk about a product really quickly?
Okay, yeah.
Yeah. So with you mentioned flow monitoring, and what might be advantageous to capturing that data is a fully sealed composite lid. We actually carry one from Trumbull Manufacturing. Nationally, we sell them coast to coast. It's a fully load rated H25 load rated composite manhole. Frame and cover. It has a EPDM seal around the frame that's captured into the frame, so it is watertight between the lid and the frame.
Yep.
But because it is made of composite, of course, one of the greatest advantages is that it's a third the weight and still has all of the load rating for heavy traffic, including trucks. But also, it allows a signal to be broadcast through the lid, whereas a cast iron lid will block a radio signal. So you could have your flow monitoring telemetry inside of the manhole with an antenna actually mounted just below the composite lid, and then you're able to broadcast the signal through the lid and capture all of that data real time. We're using it right now on the water metering side to capture information from water meters, but we can also use it in the future with your flow monitoring, as well as in the future there's a lot of talks about smart sewer systems, and I think it's something that will tie in very nicely with that.
Sure, yeah, that sounds great. Certainly, manhole great. There are lots of issues around the manhole framing grate. Getting the appropriate compaction there is difficult in the field, the way we put the asphalt on or whatever. So frame grate's always a problem. So if we have a product that could reduce the risk of I&I at that location, that would be fantastic. As you know, I've said before, I don't recommend specific products. Well, I identify issues, and then I ask suppliers to go to municipalities, get them approved, and let's do some pilot projects. Like, let's put some of these in, find a municipality that's willing to do it, put it in some divisions, do some flow monitoring, and we need results. Like, we actually need to see demonstrated performance. And I know some of these products you've installed across Canada. That's great. So now engineers, of course, are very conservative, because if I'm designing a sewer system the last 75 years, it's quite hard to recommend a brand new product. So I generally I'm generally asking other municipalities if they've used it or whatever. But we absolutely need better. We absolutely need better products. We need better products for all those places I said there's leakage happening, like connection from lateral to mainline sewer and connection of mainline sewer at manhole. Those are always weak spots in our sewer system, so we need to do better. So if guys like you can come up with ideas, come up with solutions to these problems, that would be just fantastic. And it may cost us a little bit more to put these sewers in the ground. That is the price we need to pay to not be looking at leaking sewers. The other thing I haven't mentioned about this 75-year life and all that is once inflow and infiltration starts, it starts undermining the bedding. So as the water gets into the sewer, the fines in the bedding start moving with the water. And as the fines move, the bedding shifts a little bit, and then it moves a little bit more. And then the pipe, if there's a joint a little bit open, it'll open more. So I don't think that we are installing sewers for 75-year life anymore. The sewers I'm seeing going in the ground are not going to be good for 75 years. They are going to fail before that. So not only are we costing day to day on our sewer bills, but we're compromising the long-term life of these sewers, and we absolutely cannot afford to do this. It's just we don't have the look. We do not have that money. We just can't do it.
Yeah, more attention needs to be paid toward the issue, and you're hearing it more and more. And it's great to have you on the show and to get into the details about it. And it's just eye-opening, just the cost. We haven't even talked about the environmental impact, Barbara.
Right, but let me tell you what warms the cockles of my heart is that all across Ontario now and through Canada, Ontario's, well, mostly Ontario because that's where I've done most of my work. I'm hearing from municipalities all over that are adding the requirement for flow monitoring of new subdivisions into their development agreements. Like they're just putting it in now. It's becoming a thing, which is fantastic. And the Ontario Ministry of Environment and Climate, MECP, I always want to say, and Conservation and Parks, thank you, are rewriting their sanitary sewer design standards. They haven't been updated since 1985. And they are looking at adding the requirement to get a C of A approved. They're looking at adding a requirement for flow monitoring, which would make it equal for everybody across the board in Ontario. One of the problems we see is if a big municipality, GTA municipality, decides they're going to require flow monitoring in all the new subdivisions, but the adjacent municipality doesn't put that requirement in, there's a fear that developers will go to the adjacent municipality. So, these are all things, because if we flow monitor, so many things going on upstream with all the construction activity and so many shared responsibilities that it's going to be difficult to catch every single place where I might get in. So my feeling is that's the developer's worry. I don't really care. He owns the sewer until we accept it. So that's kind of his problem. I'll let him figure out where the water's getting in. All I care about is what I see at the downstream end. So that takes the municipality right off the hook for BNI and I detectives or whatever. That is not their job in a brand new sewer that they don't own yet. Their job is to make sure it's built per specs. We have those specs. The flow monitoring can confirm. Bada bing, bada boom.
Hold people accountable. That makes a lot of sense to me. And I think that the additional cost of what you're talking about, doing a flow monitoring, holding people accountable for the proper installation practices, the added cost of that is easily offset by the savings passed on to the homeowner.
So
in treatment.
Oh yeah, treatment for sure. You can buy a flow monitor which has full telemetry. Everything's uploaded now. I can see how my flow monitors are functioning across Ontario just by going online. You can buy a flow monitor for about $15,000 capital cost, and then it might cost you $8,000 a year to operate it after that, like to have it hosted and then have an engineer or somebody have a quick look at the data for you. So we're not talking big dollars. If you recall, I said that 1 liter per second was $90,000. That's in treatment. That's not even taking into account lost capacity and lost life of the sewer and flooding. I mean, that's just treatment. So it's a joke. I mean, the cost of flow monitoring is nothing. And then you can reuse the municipality can just pull that flow monitor out as soon as they're satisfied in that one subdivision and move it to another one. They don't need to buy a new flow monitor. They last 10, 15 years. So it's an easy enough solution. And it moves the problem back to who should own the problem, which is the developer, and the guy building the sewers is the only person who can put them in the ground properly.
Very good. Okay, well, we're at the 35-minute mark. I'm wondering, should we open it up to some questions from the field? Mark, our producer here, what do you think? Okay, fair enough.
Absolutely not. No, pardon me, yes. The question was, does inflow and infiltration stop at the property line? Absolutely not. The soil conditions, all the conditions in the ground that have an impact on I&I are exactly the same. The property line isn't a magic, things are completely different on either side. It's the same soil, it's the same pipe. So there is no difference between I&I on the public side and the private side. The only difference, I suppose, is that for municipalities to deal with I&I on the private side is very complicated because a resident now owns that piece of sewer. So if you're watching and you own a home, you are the proud owner of a piece of sewer that you are responsible for maintaining. So to go back retroactively and try to get residents to repair their laterals, which many municipalities are trying to do because many of these old laterals are leaking, is really challenging. So we're working on that now. My preference would be, let's get them in the ground correctly in the first place, and then we don't have to hound residents. But looking at laterals on the private side has to be a part of, we have to look at that as part of an overall I&I problem, I&I program, because we estimate about 50% of the I&I is getting in on the private side. So we have to tackle the private side. And we're getting there. In Canada, our municipalities are getting their head around that. So.
Okay. Well, Barbara, do you have any questions for me?
Well, geez, I could talk about inflow and infiltration all day, but
all day long.
No, I would just encourage the suppliers to, I'm identifying problems and where they exist, and I encourage, solutions are badly needed. If you guys can come up with stuff that works, I'll be the first one to say, look, this looks like a great product. We have some pilot testing on it, whatever. Let's try this. So suppliers, manufacturers are an integral part of everybody's involved in this. All of us, developers, contractors, construction, regulators. It's a family problem, and we all have to work together to solve it. So
that's a great point, Barbara. And we're also ready and prepared and willing to supply products for pilot testing and different applications, just to get it out there and to get it used to ensure that it's going to be the right long-lasting product.
Yeah, and I certainly, a lot of my work has included various pilot testing projects, and I work with various manufacturers because, that's, as an engineer, I need to see how it works in the field. I want to see how it's installed. I want to see, if there are fundamental issues with the installation of a product, if it's difficult to install right away, that increases the risk because I know it's difficult to install. It's going to be easy to cut corners. So, I'm always keen on pilot projects. They're a great way to go, and we're recommending a bunch of them going forward with to solve some of the problems that we've identified here.
I guess just real quick, one more question for you, Barbara. Is there anything that a homeowner can do to right now, today, mitigate inflow?
Yes, absolutely. There's something every homeowner should do. The age of your house is probably the age of your sewer lateral. So if you're in a house, even 30 years old, I would say houses built from about 1990 forward, because of the housing boom we've seen, I would say that a lot of those sewer systems are not as well built as we would have liked. So as a homeowner, you should get your sanitary sewer lateral camera, CCTV inspected by a plumber, and see what kind of shape your lateral's in. Because often when the flooding occurs, it's because the lateral is damaged and it's leaking at the joints or whatever. And so it's kind of a known problem. It's about $350 to get a plumber to run a CCTV camera through your lateral. He'll launch it from the basement. You can keep the tape. And they'll tell you, and the plumber will tell you right there, you know what, your lateral's in great shape, you're fine. Great. Ask them, when should I CCTV it again? Like, when next? The rule of thumb is every 5 years, but I mean, whatever. But yeah, homeowners need to understand that you own that sewer just the same as you own your furnace and your roof and your gas appliances. This is a piece of infrastructure that's part of your home that needs to be maintained. Like, I know I'm a nerdy engineer, but I get the gas fitters to come every fall and inspect my furnace and my gas fireplace. I'm an engineer, I know some stuff, but I'm not a gas fitter. I just like
Right.
I just like it. I don't know what it costs, $150 or something, but it's peace of mind for my family, and I want to make sure my equipment's working correctly. I'm not wasting energy. So same with sewers. And the other thing is, if you are buying a home, whether it be a new home or an existing home, always, always, always get that lateral inspected as a condition of closing. Now, we all are familiar with home inspections, and most people get those when you buy a property. Home inspections, home inspectors are not plumbing specialists by any means. They may be plumbers, but there's no requirement. There's actually no regulation of being a home inspector in Ontario. So they're not going to look at the lateral. And without running a camera, you can't know the condition. And even if you're buying a new subdivision home, regardless of what the developer told you he cameraed or didn't camera, I would arrange to camera that lateral myself. Have a plumber do it, because then you know for sure. Keep the tape. If you ever have a flooding issue later, you may be able to use that tape in your defense or whatever to show that you were taking proactive measures to protect your property. So.
Okay. Well, Mark, I believe, do we have some information about Norton Engineering? Is it available to the folks out there? Okay, excellent. So if there's any questions for Barbara going forward, you have her contact details. Thank you so much, Barbara, for being a part of this show today. This has been terrific.
Thank you for the opportunity, Justin. Sorry if I talked your ear off. You got me talking about my favorite subjects.
No, it was very informative. Pardon me, I appreciate that. Again, thank you. I want to say special thanks to Raymond and Stephen from Proline Fittings for supporting this initiative. I think it's really for a good cause. Barbara, again, thank you so much for being part of this show. Proline Fittings, Infrastructure Solutions, Industrial Solutions. If you have any questions, please don't hesitate to reach out. Check out our website. And thanks everyone for participating today and watching the show.
Thank you so much.